Okay, so as long awaited, we are going to be doing the quadratic formula. So first question you should always ask when learning something new is, what is this good for? What do we use this for? So the quadratic formula solves quadratics that don't factor. It solves quadratics that don't factor. So we've been solving quadratics, but it's been with factoring. But there are a great many quadratics that don't factor, in which case you need another method. And that method would be the quadratic formula. We do like graphing better, or we do like factoring better because it is faster, way faster. So you always see if something can factor before you dive into the quadratic formula, because it is significantly longer than factoring. Okay, so in order to use the quadratic formula, your quadratic needs to be in standard form, which would be ax squared plus bx plus c equals 0. And a, of course, can't be 0. So really important is that your quadratic is equal to 0. This is the same thing you had to do when we were factoring. You added or subtracted all the terms to one side, you made it equal to 0, and then you used zero product property to actually solve those two factors. So this setup is the same. Get it equal to 0. Now here is the actual quadratic formula. X equals -1 times b plus n minus the square root of b squared minus 4ac, and then all of that is over a 2 times a. This is one of those formulas you're going to want to commit to memory. This is one you're expected to know how to do on your state test without a prompt. So you've got to get it memorized. All right, we're going to do a couple examples. I'm going to draw a line down the middle of the page because I'm going to do one on the left, and then I'll do some shorter ones on the right to address specific algebra dilemmas that you might run into. So example 1 is 4x squared equals 8x minus 3. Now, you know this is a quadratic because it's got an x squared on it, but it's not in standard form. Standard form has to be equal to 0. So first thing you're going to do is add or subtract all terms to the left. So subtract 8x over to the left, add 3 over to the left. That gives you 4x squared minus 8x plus 3 equals 0. Now that we are in standard form, we know that A is 4, B is -8, and C is 3. And we need to know those three things to use the quadratic formula. All right, so now we're going to take our A, B, and C, we're going to put them into the quadratic formula. So x equals -1 times B, which is -8, plus and minus the square root of b squared, so -8 squared, minus 4 times a, which is 4, times c, which is 3, all over 2 times a, which is 2 times 4. And yes, use your parentheses liberally. Don't be afraid to recheck and make sure that all your negatives are where they're supposed to be. All right, so to simplify something in this form, you can do the multiplying pair top and bottom early, and that won't hurt anything. So -1 times -8 is 8, plus and minus, and we'll address that in a second. On the bottom is 2 times 4, which is 8. So you can do the front number and the bottom number first, and then we're going to focus our attention inside the grouping symbol, which is the radical. So inside the grouping symbol, exponents first. -8 times -8 is positive 64. Then moving to the right, you're going to multiply. This, and we talked about this before when we did this formula for practice. We did that last Thursday. But you want to treat this like a -4, not like a -4. It tends to mess people up on their math if they think of it as a -4. So -4 times +4 is -16. -16 times 3 is -48. So we did the power first, and then we did multiplication. Now all we've got left on the inside is adding and subtracting. 64 minus 48 is 16. All right, now that we've simplified inside the radical, we're going to simplify the radical itself. 16 is 4 times 4, so 2 4s, 1 comes out, and we have 8 plus and minus 4 over 8. This is where you need to split the plus minus sign. You need a positive side and a negative side. So on the positive side, 8 equals x plus 4 over 8. On the negative side, x equals 8 minus 4 over 8. So you have to split it and get 2 answers. Quadratics get 2 answers. They might be the same answer twice, but you still have 2 answers. All right, so do the top first. 8 plus 4 is 12. And 12 over 8 reduces to 3/2. That's our first answer. On the negative side, 8 minus 4 is 4. And 4 over 8 reduces to 1/2. You should get fractions and very weird numbers for this, because if the numbers were nice whole numbers, you could have factored it in like 2 steps. So really, if you're getting whole numbers, then you might want to say, am I considering factoring? Because those should be factorable. So when you have multiple answers, we're going to use set notation. X is an element of the set containing 3/2 and 1/2. And those are your 2 answers. All right, we're going to do another one. Let's do example 2. So come up here on the right-hand side of your line. We have x squared plus 4x equals -5. So the very first thing you need to do is get it into standard form equal to 0. So we're going to add 5 over to the left. That gives us x squared plus 4x plus 5 equals 0. Now that it is equal to 0, I can say that a is the invisible 1 attached to the x squared, b is 4, c is 5. Now we're going to take a, b, and c and put them into the formula. So x equals -1 times b, which is 4, plus and minus the square root of b squared, so 4 squared, minus 4 times a, which is 1, times 5, which is c, all over 2 times a, which is 2 times 1. All right, like before, you can do the front pair and the bottom pair early. So -1 times 4 is -4. And on the bottom, 2 times 1 is 2. Inside the radical, the grouping symbol, we need to follow order of operations. You do the exponent first. 4 times 4 is 16. And then we're going to multiply the -4 times the a and the c. -4 times 1 is -4, times 5 is -20. Okay, now the last thing you do in order of operations is add or subtract. 16 minus 20 is -4. This is all over a 2. Now, one of the things you cannot have is a negative under the radical. That is not solvable for real numbers. So if you end up with a negative under the radical, first thing you should do is double check your math. Make sure you didn't drop a negative. But if it really does have a negative under the radical, then there is no real solution. There is actually an imaginary solution, but we don't do those in Algebra 1. So we would just say no real solution, and that would be it. You would be done. Mm-hmm. All right, example 3. This example, we're going to jump in halfway through on the problem. So you've already used quadratic formula. You've already simplified. And what you have is 4 plus and minus 2 radical 3 all over a 2. If you can divide the same number out of the first term, the scalar term, and the bottom term, you have to do that to simplify. So there's a couple ways to do this, but I think the most straightforward is just to split the two top terms over their own 2. So 4 over 2 plus and minus 2 radical 3 over 2. So 2 goes into 4 2 times. On the radical, the 2's cancel, and I get plus and minus 3. So when you have a plus minus answer, you can, when you answer, just leave it plus minus. So 2 plus minus radical 3 in your set notation, that would work. You can also split it into 2 plus radical 3 and 2 minus radical 3. That would also be an acceptable way to answer. So you do whichever one you like best. Right, I'm going to flip the page. I'm going to go to Roman numeral 2. We're going to learn about the discriminant and x-intercepts. The discriminant and x-intercepts. All right, so what I want you to do is right underneath that title, I want you to draw 3 mini graphs. They don't have to be perfect. These are going to be sketches, not actual graphs. All right, so when you solve something with the quadratic formula, there's basically 3 different scenarios that can happen. We're going to sketch the scenario and also say how many solutions it has. Now, in example 1, where we got 2 solutions, that means that the parabola of that quadratic is going to cross the x-axis in 2 places. Whether it's opening up or down, it still crosses the x-axis twice. So because it crosses the x-axis twice, we have 2 real solutions. Those are the ones that we listed. Another way to interpret 2 real solutions when graphing is as x-intercepts. 2 real solutions means 2 x-intercepts. And you would take your solutions that you just found using the quadratic formula, and you would make them into points. B sub 1 comma 0, B sub 2 comma 0. And those are the intercepts. So your solutions are the intercepts. Now, if all you want to know is how many solutions there are and what type, but you don't actually need to know the solutions, one shortcut to doing that is to use what's called the discriminant. The discriminant is the part that's under the radical, the b squared minus 4ac but no radical, just the interior parts. If your discriminant ends up being a positive number, so if b squared minus 4ac is greater than 0, then you have two real solutions. Okay, sometimes when you do these problems, you're going to end up with the same solution twice. So what happens, this is kind of rare, but if there's only one solution, it happens twice, it means the vertex of your parabola just barely touches the x-axis and nothing else. So it only touches in one place, whether it's opening up or opening down. There's only one x-intercept. That means there is only one real solution, which means there is one x-intercept. And you would take your one solution and put it with a comma 0 as the x-intercept. You can verify this with the discriminant. If b squared minus 4ac equals 0, then you have one real solution. And you can do that before you actually do the entire quadratic equation, just to make sure you know what you've got. Okay, the third scenario is your parabola does not cross the x-axis. It floats in space, either opening up or opening down. It does not cross at all. That means there are no real solutions, just like what we did on the previous page where we got no real solution. It means there are no x-intercepts. Doesn't cross anywhere. And the discriminant can tell you this. If b squared minus 4ac is less than 0, if it's a negative number, that means there was a negative under the radical and there is no real solution. So the discriminant is used as primarily a shortcut to figure out how many solutions there are and what type. That's the purpose of the discriminant. All right, let's practice using the discriminant. Let's say you've got y equals x squared minus 2x minus 3. And on your worksheet, it will ask you how many and what type of solutions. They're not going to ask you for the solutions. They just want to know how many and what type, which means you're going to use the discriminant. All right, so the discriminant is b squared minus 4ac. So looking at your equation, a is 1, b is negative 2, c is negative 3. And put that into the discriminant formula. So b squared is negative 2 squared minus 4 times a, which is 1, times c, which is negative 3. Just like before, powers go first. Negative 2 times negative 2 is positive 4. And then you're going to take that negative 4 and multiply it to the right. Negative 4 times 1 is negative 4. Negative 4 times negative 3 is positive 12. And 4 plus 12 is 16. This is greater than 0. So this follows this first graph right here. We know we have two real solutions or two x-intercepts, depending on what they're asking. So that's how you use it. It's pretty quick. All right, the very last thing we're going to do today, we're going to find the x-intercepts of a quadratic. And when you do x-intercepts, it's basically the same as trying to find solutions. You still make it equal to 0. you still use the quadratic formula. The biggest difference is your answers are going to be points, comma 0, versus just a couple of numbers. So let's say you've got 0 equals x squared minus 2x minus 3, and we're going to find the x-intercepts. So this is already equal to 0. So my a is the invisible 1, my b is -2, my c is -3. All right, let's write the quadratic formula for practice here. X equals -1 times b plus and minus the square root of b squared minus 4ac all over 2 times a. And the more times you write that, the easier it will be to remember it. Here we go, subbing in. -1 times b, which is -2, plus and minus the square root of b squared, so -2 squared, minus 4 times a, which is 1, times 3, which is my c, all over 2 times a, so 2 times 1. So again, we're doing the exact same process as solving. We're just going to write our solutions as intercepts. All right, -1 times -2 is 2. On the bottom, 2 times 1 is 2. Now let's look at the quadratic. -2 times -2 is +4. And I'm going to shortcut this a little bit. -4 times -3 is +12. So 4 plus 12 is 16. 16 is a perfect square. 2 4s. 1 comes out. I get 2 plus and minus 4 over 2. So we're going to split this into 2 plus 4 over 2 and 2 minus 4 over 2. One gets the plus, one gets the minus. On the positive, 2 plus 4 is 6, divided by 2 is 3. On the negative, 2 minus 4 is -2, and -2 divided by 2 is a -1. Here's the only difference between solving and finding the intercepts is when you're going to find the x-intercepts, you're going to list them as intercepts. So it's going to be 3, 0, and -1, 0. Those are your x-intercepts. Are there any questions?